All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on functions and variables. But odds are many of you, most of you, have never actually programmed before, so let's start by doing just that. Let me go ahead here and open up my computer, and on it a program called Visual Studio Code, or VS Code, which is just a very popular program nowadays for actually writing code. Now, you don't have to write code using this particular tool. In fact, all we need at the end of the day is a so-called text editor, a program for writing text. And heck, if you really want, you could even use something like Google Docs or Microsoft Word. You'd have to save it in the right format. But really, at the end of the day, all you need is a program for writing text, because that's what code is, text. Now, within this particular program, I'm going to have the ability to create one or more files via this top portion of the screen. And I'm going to do so by diving right in and doing this at the bottom of my screen. At the bottom of my screen is a so-called terminal window. And this is a command line interface, or CLI, interface to the underlying computer, be it your Mac or your PC or even some server in the cloud. And what I'm going to do here is literally write code and then the name of the file that I want to code, for instance, hello.py. As we'll soon see, any program that you write in Python generally has a file name that ends in .py to indicate to the computer that it's indeed a program written in Python. Now, you'll see here at the top of my screen, I have a blinking cursor, a line 1, which is where the very first line of my code is going to go, and then just a tab that reminds me of the name of this file, hello.py. And without even knowing much Python, I'm going to write my very first program here as follows. Print, open parenthesis, quote, hello, comma, world, close quote, and close parenthesis. And you'll see that at my keyboard, some of my thoughts were finished for me. I only had to type one parenthesis, and the other one automatically appeared. And that's just a feature that we'll see of tools like this tool here. Now, even if you've never programmed before, odds are you can guess, infer what this simple program is going to do. And it's only one line. Print, open parenthesis, quote, hello, world, close quote, close parenthesis. Indeed, when I run this program, ultimately, it's just going to say hello to the world. And in fact, this is a very famous, perhaps the most canonical program that you can write as your very first program in Python or any other language. And so that's what I've done here. But on my Mac, my PC, even my phone, I'm generally in the habit, like you, of running programs by double-clicking an icon or just tapping on the screen. But I see no such icons here. And in fact, that's because my interface to at least my current Mac or PC or some server in the cloud is, again, only a CLI, command line interface, which even though it might feel like it's a step back from the menus and buttons and icons that you and I take for granted every day, you'll find, we think, that it's ultimately a much more powerful interface and incredibly popular to use among programmers in the real world. So to run this program, I'm going to have to use a command. And I'm going to move my cursor back down to the bottom of the screen here, where previously I already ran one command, the command code, which has the effect of opening VS Code in my computer. And then I passed in the name of the file that I wanted to code up. Now I have a chance to type a second command, and you'll see I see a second $sign. Now, the $sign here doesn't indicate any kind of currency or money. It just is the symbol that's generally used to indicate your prompt, where the command line interface wants you to put those commands. Now, the command I can run here is going to be this. I'm going to run Python of hello.py. Now, why is that? Well, it turns out that when I actually write code in a language like Python, it's, of course, stored in that file, hello.py. But I need to interpret the code, top to bottom, left to right, so that the computer knows what to do. Indeed, at the end of the day, even if you don't really know much about computers, you've probably heard that computers only understand zeros and one, the so-called binary system. Well, if that's the case, then something that says print and parenthesis and quote unquote hello world is not surely zeros and ones. We have to somehow translate it into the zeros and ones that the computer understands. Now, fortunately, so long as you've installed such a program in advance, there's a program as well as a language called Python. So Python is not only a language in which we're going to write code, it's also a program, otherwise known as an interpreter, that you install for free on your own Mac or PC or some server in the cloud. And you can then run that program, that interpreter, passing to it as input the name of your file, like mine here, hello.py. And then that program, that interpreter, will handle the process of reading it top to bottom, left to right, and translating it effectively into those zeros and ones that the computer can understand. So let's do just that. Let me go back to VS Code here. I already typed out Python of hello.py, but I didn't yet hit enter. And that's what's now going to kick off this command. And hopefully, if I didn't mess any of this up, I should see my very first program's output to the screen. And voila, hello world. So if you too have typed exactly that same code and have executed exactly that same command, you will have written your very first program, in this case, in Python. Well, now let's take a step back and consider what is it that we actually just did and what is it we're looking here on the screen. Well, first and foremost, in most any programming language, you tend to have access to what are called functions. A function is like an action or a verb that lets you do something in the program. And generally speaking, any language comes with some predetermined set of functions, some very basic actions or verbs that the computer will already know how to do for you, that the language really will know how to do for you, and you, the programmer, the human, can use those functions at will to get the computer to do those things. Now, the program in question here, hello.py, is using one function. And you can perhaps guess what it is. That function is, of course, going to be this function print. And that print function, of course, doesn't print some preordained string of text. That is to say, it prints whatever it is you want it to print. And here, too, do we have another piece of terminology in the world of programming, namely arguments. An argument is an input to a function that somehow influences its behavior. The people who invented Python, of course, didn't necessarily know what it is you and I are going to want to print to the screen. So they designed this print function using these parentheses with the ability to take as input some string of text, be it in English or any other human language, that is what you want this function ultimately to print onto the screen. And what is it that the program's ultimately doing on the screen? Well, it's printing, of course. It's showing us hello world on the screen. And that's generally in programming known as a side effect. It can be visual, it can be audio. In this case, it's something that appears on the screen. And functions, therefore, can indeed have these side effects. One of the things they can do as this verb or action is to display on the screen as a side effect something like those words that we wanted, hello world. So that's my first program. And, I'm feeling pretty good. Everything worked as planned. I didn't make any mistakes. But honestly, when you're learning how to program, and even once you've learned how to program years later, you're going to make mistakes. And those mistakes, of course, refer to a term you might already know, which is that of a bug. A bug is a mistake in a program. And they can take so many forms. And take comfort, perhaps, in knowing that over the coming weeks, you're going to make so many mistakes. You're going to have so many bugs in your code, just like I did, and just as I still do. And those bugs themselves are just mistakes that are problems for you to solve. And over the weeks to come, we're going to give you a lot of tools, both mental and technical, via which you can solve those problems. But just don't get discouraged if when writing your program for the first time, it doesn't even work that first time. It will, with time, with practice, and with experience. So let me deliberately now make a mistake that there was a non-zero chance I might have done accidentally already, but I got lucky. Let me go ahead and just suppose I forgot to include something like the closing parenthesis at the end of this line of code. The code is almost correct. It's like 99% of the way there. But now that I've pointed it out, it's pretty obvious that it's missing that closed parenthesis. But even little, seemingly minor details like that you and I as humans wouldn't really care about. And if you're sending an email or a text message, whatever, it's just a typo. It's not that big a deal. It is going to be a big deal to the computer. A computer is going to take you literally, and if you don't finish your thought in the way the language expects, it's not going to necessarily run at all. So let's do this. I'm going to go ahead here and clear my screen down at the bottom, just so I can start fresh. And I'm going to go ahead and run this version of my program after having made that change by deleting the parenthesis. I'm going to go ahead and type Python again of hello.py. And this time when I hit enter, I'm hoping I'm going to see hello world, but here we have an error on the screen, a so-called syntax error, which refers to my having made a mistake at my keyboard. And this one, fortunately, is pretty straightforward. It indeed says that this open parenthesis was never closed. And so that's probably pretty intuitive now what I need to do. I need, of course, to close it. Unfortunately, sometimes the error messages we'll see in the coming weeks are not going to be nearly that user-friendly. But there, too, again, with experience, with practice, will you get better at debugging such programs. Let me now make sure that I indeed fixed it correctly. Let me go ahead and run now hello.py and hit enter. And voila, we're back in business. Well, let me pause here and see if we have any questions now about Python itself, writing or running even the simplest of these programs.
Could I write code inside a Word or, for example, Microsoft Excel? And what's the barrier to doing that?
A really good question, and allow me to very explicitly say to the entire internet that you should not write code with Microsoft Word. I mention that only because it's a tool via which you can write text, and code is at the end of the day just text, but it's not the right tool for the job. We don't need bold-facing, underlining, paragraphs, and the like. We generally want something much simpler than Microsoft Word or Google Docs, and so VS Code is an example of just a more general-purpose text editor. Its purpose in life is to allow you, the human, to edit text. Nowadays, these text editors come with many more features. In fact, you'll notice that even in my code here, even though it's just one line, there's a bit of color to it. The word print for me is appearing in blue. The parentheses are black. And we'll see as we might write more lines of code, more and more of the lines will come to life in various colors. Now, that's just one feature of a text editor. We'll see, too, that it has features like this built-in terminal window. It's going to have a built-in tool for debugging or finding problems with code. And it's just a very popular tool nowadays. But there are many, many others out there. You're welcome to use them for this course and beyond. We just happen to use this one in large part too because you can also use VS Code nowadays for free in the cloud. How about one other question here on programming with Python or Hello World or syntax more generally?
Okay, I was trying to ask if it is not possible to run the code without using the terminal window.
I think I heard, is it not if it's possible to run the program without the terminal window? Are you?
Yes, sir.
OK, you froze for me again, but let me infer what the question is. So in this environment, as I've configured my computer, I can only run these Python programs via the terminal window. Now, that's good for me, the programmer, or the person who's trying to learn how to program, but it's not very good if you want to ship this software and have other people use your actual code. You can absolutely write programs and then allow other people to use not a command line interface, but a graphical user interface, or GUI, G-U-I. This is just one mechanism, and perhaps I think the best one with which to start writing code, because eventually it's going to give us a lot more control. Allow me to forge ahead here, but please feel free to continue asking questions along the way, if only via the chat. And let's consider now how we might go about improving this program. Let's go about improving this program to make it a little more interactive and not just assume that everyone is going to want to be greeted more generically as hello world. Let's see if I can't get this program to say something like hello David, or hello Jeremiah, or hello Horatio, or whatever the actual user's name is. Well, to do this, I'm going to go back up to hello.py, and I'm going to add another line of code at the very top that simply says, for instance, what's your name, quote unquote, with an extra space at the end. So I'm printing to the user, asking them a question for some input, but now I need another function to actually get input from the user. And perfectly enough, Python comes with a function named input. So here I'm going to go ahead and call a function input, open paren, close paren. And that's going to prompt the user with just a blinking cursor waiting for them to type something in. Now, it turns out if I read the documentation for the input function, it actually takes an argument itself. I don't need to use print separately and then prompt the user for input. So I can actually simplify this code before we even use it. I'm going to go ahead here and take that same string from print, put it as an argument to the input function, and get rid of the print altogether. And in fact, that print would have added a new line anyway. So now I've just got a prompt where the user's cursor is going to end up blinking at the end of the line, asking them, what's your name? In my terminal window, I'm going to run Python of hello.py, enter. OK, we're making progress. It seems that this new function input is indeed prompting me, the human, for input. So I'm going to type in my name, David, and hit enter. Unfortunately, it doesn't really do anything with my name. It just outputs it immediately. All right, well, I could fix this, right? I could go up to line 2, and I could change world to David. And then back in my terminal window here, I can do Python of hello.py, enter. What's your name? David, enter. And there we go. All right, now I'm up and running. Now my program is working as intended. Of course, this isn't really working as intended here. Let me go ahead and try pretending to be my colleague Carter here. Well, Carter's name is this. I'm going to go ahead and hit enter, and I'll see, of course, hello Carter. Well, obviously not, because I've hard-coded, so to speak. I've written literally my name inside of the string. So we need some way now of actually getting back what the user's input is and doing something with it ultimately. And for this, we're going to leverage another feature of programming, specifically a feature of some functions, which is that they can have return values as well. If you think of input as being, again, this action, this verb, you can actually personify it as maybe a person, like a friend of yours that you've asked a question of. And you've asked your friend to go get input from someone else. Go ask that person their name. And if your friend comes back knowing that person's name, well, wouldn't it be nice if they handed that name back to you? That's kind of what we need metaphorically the function to do, is get the user's input and then hand it back to me so that I, the programmer, can do something with it. But if it's going to be handed back to me, I kind of want to put it somewhere so that I can then print it back on the screen. I need to do the equivalent of take out like a piece of paper or a Post-it note, write down on this piece of paper what it is the human has said so that I can then feed it into as input that print function. And to do that, we're going to need one more feature of programming, namely variables. And odds are most everyone's familiar with variables from math class way back when, x and y and z and the like. Well, programming has that same capability, this ability to create a variable, in this case in the computer's memory, not just on a piece of paper, and that variable can store a value, a number, some text, even an image or video or more. A variable is just a container for some variable. A variable is just a container for some value inside of a computer or inside of your own program. So how do I go about expressing myself in this way? Well, I think what I'm going to do is introduce a variable that's a little more interestingly named than x or y. I could just say this, x equals input, but I'm going to use a better name than a typical mathematical variable here, and I'm going to literally call my variable name. Why? Well, in programming, because I have a whole keyboard in front of me, I can use more descriptive terms to describe what it is I'm writing. And now, though, there's an opportunity to consider a specific piece of syntax. We've seen parentheses. We've seen quotes, all of which are necessary when passing inputs to a function. But this equal sign here that's in between input on the right and name on the left is actually important. And it's technically not an equal sign per se. It doesn't mean equality as much as it means assignment. So in Python and many programming languages, a single equal sign is the assignment operator. And what that means specifically is that you want to assign from right to left whatever the user's input is. So the equal sign copies from the right to the left whatever the return value of the function on the right is. So again, the input function clearly gets input from the user. That's why I was able to type my name or Carter's. But it also sort of behind the scenes hands that value, that return value, back to me, the programmer. And if I use an equal sign and a variable, no matter what I call it, I can store that input in that variable so as to reuse it later. So now sitting in the computer's memory somewhere is a container containing David, quote unquote, or Carter, quote unquote, or whatever the human has typed in. But here it's easy to make a mistake. Suppose I decide to try to print that name. And so I kind of, on a hunch, type in this, hello, comma, name, just kind of plugging in the name of the variable. Well, let me go ahead here and run Python of hello.py and hit enter. That's going to prompt me for my name. And let me type in my name, D-A-V-I-D, but I haven't hit enter yet. And perhaps via the chat, what's going to happen here when I now hit enter? I'm hoping it says, hello, David. I'd be OK if it says hello, world. But I don't want it to say what it's actually going to say. And yep, what we're seeing in the chat is, well, it's probably going to say literally hello, comma, name. So that's not quite right. So we need another way of printing out the value inside of that variable rather than just this word name. Well, let me try this in a couple of different ways. Let me try this as follows. Let me go ahead and maybe undo this because I've gotten pretty good already at saying hello. So let's draw that line in the sand and just say, all right, let's at least get hello, comma, out the door. Let's now print name. And just on a hunch, I'm going to try this. I'm going to use print again, because you can use these functions as many times as you need. And I'm going to pass to the print function the variable called name. But notice, I'm being a little clever now. I'm not putting it in double quotes, because we've seen already that double quotes means literally print out N-A-M-E. I'm getting rid of the quotes this time in hopes that now by passing the variable called name to the function called print, it will in fact go about printing the contents of that variable, that is, its so-called value. All right, let's go ahead and do this here. Python of hello.py, enter. What's your name? David. And now, crossing my fingers still, I see hello, comma, David. All right, so it's not the best program. I'm kind of cutting some corners here, so to speak. I'm saying hello, David. on two separate lines. So it's not as elegant, it's not as pretty, it's not as grammatically appropriate in English as just saying it all in one breath on one line, but at least I've solved the problem, just not very well yet. But let me take a step back now and perhaps introduce a couple of other concepts with which we should be familiar, which is as our programs get longer and they're no longer just one line or two or even three, eventually our programs are going to become dozens of lines, maybe even hundreds of lines long. Let's set the stage for success moving forward. It turns out that Python and a lot of programming languages also support something called comments. Comments are notes to yourself in your code. And you include comments by way of a special symbol. In Python, it's going to be the hash symbol, typically. And that allows you to write the equivalent of a note to yourself, but in a way that's not going to break your code. The computer actually ignores your comments. It's just there for you. It's just there for your teacher. It's just there for your colleague with whom you're sharing ultimately that code. So if I go back to VS Code here, and I just want to add some comments to this program to explain to my teacher, to myself, to my colleagues what this program is doing, well, let's go ahead and do that. I'm going to go at the very top of my program. And on line 1 now, I'm going to move that original line of code down a bit. I'm going to add a hash. And I'm going to say something like this, ask user for their name. Now, I don't have to use that language. I don't have to use that, that text. I could use any human language whatsoever. It doesn't have to be English. But I'm going to now, below that, just say something like this, say hello to user. And you'll notice that VS Code by default is kind of graying out my comments. They're no longer blue. There's no red. There's no color in them. And that's just because they're notes to myself, and the computer ultimately is going to ignore them. But what we have now is two comments, ask user for their name, and then a second comment, say hello to user. And I've just kind of commented each chunk of code, like each line or lines plural of code that are doing something noteworthy. Why? Well, tomorrow morning when I wake up, having slept for quite some time, forgotten what it is I did the previous day, it's convenient with comments to just see in English or your own human language what it is this program is doing so that you don't have to read the code itself. And better yet, if there's maybe a mistake down the road, you can read what your intention was, and then you can look at the code and figure out if your code's now doing what you intended. So this isn't really necessary for a program this small. It's pretty obvious with just 1 or 2 or 3 lines what the program's doing. It's just as fast to read the code than the comments. But getting into this habit is generally a good thing, to comment your code every 1 or few lines so as to remind yourself and others what it is your intent and your code is doing. What's nice about comments, too, is this. Comments can also serve to be sort of a to-do list for yourself. There's this notion in programming of pseudocode. Pseudocode isn't a formal thing. It's not one specific language. It's just using English or your own human language to express your thoughts succinctly, methodically, algorithmically, so to speak. But pseudocode, therefore, because it's not Python and it's not necessarily English, it just kind of allows you to outline your program even in advance. So for instance, if I wasn't sure today how I wanted to go about writing this program, but I did know what I want to do, I could have started today by just writing this in hello.py. No code. I could have written just a couple of comments to myself. Step 1, ask user for their name. Step 2, say hello to user. Then, once I've outlined my program in pseudocode, then I can go in there and say, all right, how do I ask the user for their name? Well, I can do input, quote unquote, what's your name, question mark. And then on the left here, I can maybe put a variable and assign it to that. OK, how do I say hello to the user? Well, I know I can use print to say things on the screen. Let me say hello, comma. And let me now print the person's name. So again, pseudocode is a nice way of structuring your to-do list, especially if you have no idea how to write the code, because it breaks a bigger program down into small, bite-sized tasks. All right, let me pause here to see if there are now any questions on comments, pseudocode, return values, or variables. Any questions we can clear up here?
Yeah, my question is, does the function input work for any type of information or only for words?
Yeah, really good question. So according to its documentation, and we'll look more at formal documentation soon, input is going to expect what's called a string. That is a sequence of text, be it in English or any other human language, but it's indeed going to be expecting text with which to prompt the user. A good question. How about another question from the group, if we could?
I wanted to ask how I make several line comment.
Oh, how do you do many lines of comments, if I'm hearing you correctly? Sure. You would just keep doing them like this. You just prefix each of the lines with a hash symbol, like I'm doing here. There is another technique for doing multi-line comments in Python that actually tend to have special meaning. You can do 3 double quotes like this, and then anything in between here is a comment. That's another technique, or you can use single quotes as well, but more on those, I think, another time. All right, well, if you don't mind, let me forge ahead here and see how we might improve this program further and also introduce a few other features that we might want to take into account over time. So it turns out that we can certainly improve on this program because it's a little disappointing that I'm cutting this corner and saying hello, comma, and then on a new line, printing out name. Like, we can do better. And most programs you use on your phone or your laptop certainly keep text together when people want. So how can we go about doing that? Well, there's a few different ways. And in fact, the goal here is not so much to solve this one problem, but to demonstrate and emphasize that in programming, Python and other languages, there's so many ways sometimes to solve the same problem. And here's one way to solve this problem. Let me go in here, and let me go ahead now and say hello, comma, and let me just add to the end of that the user's name. So I'm using plus in kind of an interesting way. This is not addition per se. I'm not adding numbers, obviously. But I do kind of want to add the person's name to the string of text, hello, comma. Well, let me go now down to my terminal window and run Python of hello.py again. Enter. What's your name? I'm going to type in David. Enter. OK, it's better. It's better, but there's a minor bug, albeit aesthetic here. There's missing space, but let's just use some intuition here. Well, if I'm missing the space after the comma, why don't I go ahead and just add it manually here? Let me now rerun the program, Python of hello.py, enter, David, enter, and there we go. Now we have something that looks a little prettier in terms of English grammar, hello, comma, space, David. And now if we rewind, you might have noticed before or wondered why I had this seemingly extra space after my question mark, namely here. There's a space after the question mark but before the double quote, and that was just for aesthetics too. I wanted to move the user's cursor one space to the right so that when I type their name, or they type their name, it's not immediately next to that same question mark there. But there's other ways we can do this. It turns out that some functions, print among them, actually take multiple arguments. And it turns out that if you separate the inputs to a function, the so-called arguments to a function with a comma, you can pass in not just 1, but 2, 3, 4, 5, onward. So let me go ahead and pass in not just hello, comma, space, but that followed by name. And this is a little confusing potentially at first glance, because now I've got 2 commas, but it's important to note that the first comma is inside of my quotation marks, which is simply an English grammatical thing. The second comma here is outside of the quotes, but between what are now 2 separate arguments to print. The first argument is hello, comma, space. The second argument is the name variable itself. So let's see how this looks. Python of hello.py, enter. What's your name? David, enter. OK, I've kind of overcorrected. Now I've got 2 spaces for some reason. Well, it turns out, and this is subtle, when you pass multiple arguments to print, it automatically inserts a space for you. This was not relevant earlier because I was passing in one big argument to print all at once by using that plus operator. This time I'm passing in 2 because of the comma. So if I don't want that extra space, I don't need to pass in one myself. I can just do this. And now notice if I run this program again, Python of hello.py, type in my name, David, now it looks grammatically like I might want. Now, which of these approaches is better? This approach uses a function print with 2 arguments, hello, comma, and the name variable. The previous version, recall, technically used 1 argument, even though it looked a little curious. It's 1 argument in the sense that the computer, just like mathematicians, are going to do what's inside of parentheses first. So if inside of parentheses you have this string of text, hello, comma, and a space, which I need to add back, then you have a plus, which means not addition per se, but concatenation, to join the thing on the left and the thing on the right. This ultimately becomes the English phrase, hello, comma, space, David. And then what's being passed ultimately to the function is technically something like this. But it's doing it all dynamically. It's not me typing in David as I discreetly did earlier. It's figuring out dynamically what that value is after concatenating hello with the value of name and then passing that ultimately to print as the sole argument. Let me pause here to see if there's any questions on numbers of arguments now to functions.
Can we use a function many times to solve a certain problem which we can encounter many times in our code?
You can. You can use a function many different times to solve some problem. What we'll soon see, though, is if you find yourself as the programmer solving a problem the same way again and again and again, it turns out you'll be able to make your own function so that you don't have to keep reusing the basic ones that come with the language.
I was curious about the comma and the plus sign. So after plus sign, can we give just one variable, and after comma, can we give multiple variables? Like, what is the difference?
A good question. So in the context of strings, and I keep using that term, string is a technical term in a programming language. And again, it means a sequence of text, a character, a word, a whole paragraph even. So the plus operator is not just used, as we'll see, for addition of numbers in Python like we do on paper pencil, but it also is used for concatenation of strings on the left and the right. If you did want to combine not just two strings, left and right, but a third and a fourth, you can absolutely keep using plus, 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 and chain them together just like in math. Eventually, that's going to start to look a little ugly, I dare say, especially if your line of code gets long. So there's better ways that we'll actually soon see. And a good question as well. Well, let me come back to the code here in question and see if we can show you just a couple of other ways to solve the same problem, along the way emphasizing that what we're technically talking about here, yes, are strings, but there's even a technical term for these strings. In Python, it's just str, so to speak, str for short for string. As you may know, if you programmed in other languages, people who invent programming languages like to be very succinct, to the point, so we tend to use fairly short phrases to describe things, not necessarily full words. So while you might say string, technically in Python what we're really talking about, these sequences of text, are technically strs. This is an actual type of data in a program. But we'll soon see that there's other types of data in programs as well. In fact, let's see if we can't improve this in one other way. I like the progress we've made by keeping everything on the same line. Hello, comma, David. All on the same line. What more, though, could we do in terms of solving this problem? Well, it turns out that we didn't have to give up entirely with using print twice. Let me rewind a little bit and go back to that earlier version where I wasn't really sure how to solve this problem. So I was using print once to print out just the hello and the space and the comma. And then I used print again to print name. That, strictly speaking, wasn't bad, but there was this visual side effect that I just didn't like. It just looked ugly to have these two lines of text separate from one another. But there's another way to fix this. Clearly, it seems to be the case that the print function is automatically outputting a blank line. It's moving the cursor automatically for me to the next line, because that's why I'm seeing hello on one line and David on the next, and then my prompt, the $sign, on the line below that. So print seems to be presuming automatically that you want it to move the cursor to the next line after you pass it some argument. But you can override that behavior. Again, functions take arguments, which influence their behavior. You just have to know what those arguments are. And it turns out that if we look at the documentation for Python's print function, we can actually look up at this URL here. docs.python.org is where all of Python's official documentation lies. If I poke around, I can find my way to, more specifically, this URL here, where I can find all of the available functions in Python and the documentation therefore. And if I go a little more precisely, I can even find specific documentation for the print function itself. And rather than pull that up in a browser, I'm going to go ahead and highlight just one line from that same URL, which is this. And this is easily the most cryptic thing we've seen yet. But this is the official documentation for the print function. And one of the best things you can do when learning a programming language is honestly learn to read the documentation, because truly all of the answers to your questions will in some way be there, even though admittedly it's not always obvious. And I will say too, Python's documentation isn't necessarily the easiest thing, especially for a first-time or a novice programmer. It too just takes practice, so try not to get overwhelmed if you're not sure what you're looking at. But let me walk you through this example. This, again, is a line of text from Python's official documentation for the print function. What this indicates as follows is this. The name of this function is, of course, print. Then there's a parenthesis over here and another closed parenthesis way over there. Everything inside of those parentheses are the arguments, the potential arguments to the function. However, when we're looking at these arguments in the documentation like this, there's technically a different term that we would use. These are technically the parameters to the function. So when you're talking about what you can pass to a function and what those inputs are called, those are parameters. When you actually use the function and pass in values inside of those parentheses, those inputs, those values are arguments. So we're talking about the exact same thing. Parameters and arguments are effectively the same thing, but the terms you use from looking at the problem from different directions when we're looking at what the function can take versus what you're actually passing into the function. So what does this imply? Well, this syntax is pretty cryptic. But at the moment, just know that an asterisk, a star, and then the word objects means that the print function can take any number of objects. You can pass in 0 strings of text, 1 string like I did, 2 strings like I did, or technically infinitely many if you really want, though that code's not going to look very good. After that, we see a comma. Then we see another parameter here called sep, short for separator in English. And notice the equal sign and the single quote, space, single quote. So quote unquote space. I don't know what that is yet, but I think we've seen a hint about it. Let's focus, though, for a moment on this. The print function takes another parameter called end, and the default value of that parameter is apparently, based on this equal sign and these quotes, \n. And what is \n, if you'd like to chime in the chat? Anyone who's programmed before has probably seen this, though if you've never programmed before, this might look quite cryptic. \n means new line. And it's a way textually of indicating if and when you want the computer effectively to move the cursor to the next line, create a new line of text. And so technically, if we read into the documentation, we'll see more detail on this. The fact that there's a parameter called end in the documentation for the print function just means that by default, this print function is going to end every line with \n. You don't literally see \n. You see a new line. You see the cursor moving to the next line. Now, by that logic, let's move backwards. Sep for separator. The default value of separator is apparently a single blank space. Well, where have we seen that? Well, recall in an earlier example when I passed in not just 1, but 2 arguments to the print function, recall that they magically had a space between them. In fact, they had that space plus my own space, and that's why I deleted my space, because at that point it was extra. So this just means that when you pass multiple arguments to print, by default they're going to be separated by a single space. By default, when you pass arguments to print, it's the whole thing is going to be ended with a new line. Now, just by knowing this, and let me literally wave my hand at the rest of the documentation for another day. There's more things that print can do, but we're going to focus just on sep and on end. Let's see if we can't leverage this now to solve that original problem. The original problem was this. I don't like how hello, comma, David is on 2 different lines. Well, that's happening again because print is automatically printing out a new line. So let's tell it not to do that. Let's tell it by passing a second argument to the first use of print to say end equals quote unquote, not \n, which is the default automatically. Let's make it quote unquote nothing else. Let's override the default value so there is no new line. There's literally nothing there. And let's see what happens. Let me now go down to my terminal window and clear it. And I'm going to run Python of hello.py enter. I'm going to type in my name, David. And I think now everything's going to stay on the same line because, and it did, this line here, 5, is going to print out hello, comma, space, but then nothing at the end of it because I changed it to be quote unquote. The second line is going to print the name, David, or whatever the human's name is, and it will move the cursor to the next line because I didn't override the value of end there. Just to see this more explicitly, if you do something cryptic like, well, I have no idea what's going on. Let me just put in temporarily 3 question marks here. We'll see the results of this too. Let me go back down to my terminal window, run Python of hello.py, what's your name, David, and now you see literally really ugly output, but you see literally what's going on. Hello, comma, space, then 3 question marks end that print statement, and then you see DAVID. So not a good outcome, but it demonstrates just how much control we have here too. And let me rewind further. Recall that in our other version of this, when I passed in hello, comma, and name, they were separated by a single space. So Python of hello.py, DAVID, enter. That just worked. Well, what if we override the value of sep for separator? Instead of being 1 space, we could say something like question mark, question mark, question mark, just to wrap our minds around what's going on there. Let me now do Python of hello.py, david enter, and you see two. These two inputs, hello comma, and the name are now separated in an ugly way by 3 question marks because I've overridden the default behavior of sep. And even though the documentation uses single quotes, I've been in the habit of using double quotes. In Python, you can use either. Strictly speaking, it doesn't matter, but you should be consistent. And I generally always use double quotes. Python's documentation, though, always uses single quotes. Questions now on these types of parameters. And allow me to propose that we give these an official name. Up until now, when we've been passing values to print, those are called positional parameters. Positional in the sense that the first thing you pass to print gets printed first. The second thing you pass to print after a comma gets printed second, and so forth. But there's also these things we've now seen called named parameters, named SEP, separator, or end, END, for the line ending. Those are named parameters because, one, they're optional, and you can pass them in at the end of your print statement, but you can also use them by name.
This may be a weird question, but I was wondering, what if someone wants to like add actually quotation marks within the quotation marks?
Yeah, I like how you think. This is what we would call a corner case, right? Just when we've made, right? This is all sounding great, at least as programming goes. But wait a minute, what if you want to print a quote? That's a really good question. Well, let's see if we can't figure this out. Suppose that I want to print out not just the user's name. Let me simplify this further. Let me go ahead and get rid of a lot of this. And let me just say something like, hello. Maybe I'm being a little sarcastic here. Hello, friend. You know, in that kind of tone. Well, this is not going to work, actually, because you are trying to use quotes to be like friend in finger quotes, but you're also trying to end the sentence. And if I try running this, let's do this. Python of hello.py, you'll see that this is just invalid syntax. Perhaps you forgot a comma. And this is actually a bit annoying. Sometimes the error messages you see are misleading. Like the computer, the language doesn't really know what's going on, so it gives its best guess, but it's not necessarily correct. But I can solve this problem in a couple of ways. I can do this. I can change my outermost quotes to single quotes, because recall a moment ago I said you could use double quotes or single quotes so long as you're consistent. So that's fine. If you use single quotes on the outside, you can then use double quotes on the inside, and you'll see them literally. So for instance, if I run Python of hello.py, there we go, hello, friend. But there's another way. If you insist on using double quotes, as you might want to, just to be consistent, you can also use that backslash character again. We saw the backslash n a moment ago, and that meant we don't want a literal n to be in the output. We wanted a new line. So the backslash actually represents what's called an escape character. An escape character is one that you can't just type necessarily once on your keyboard. You need to express it with multiple characters. So I can actually put backslashes in front of these inner double quotes so that the computer realizes, oh, wait a minute, those aren't quotes that finish or start the thought. They're literal quotes. So now let me go back to my terminal window, run Python of hello.py, enter, and now it's working as well. So escaping is a general technique that allows us to do that too. And if I may, let me rewind now on these examples and go back to where we left off with my code. I'm just undoing all of that because I want to get back to the point ultimately of specifying now a final way of solving this problem. Well, it turns out that we have yet another way we can solve this problem, which is perhaps the most frequently done now, or at least the most elegant when it comes to setting us up for longer and longer uses of strings. You can use a relatively new feature of Python that allows you to do this. You can literally put not the name of the variable like that in your string, because we already saw this is wrong, right? If you do this, you will literally see hello, comma, name. But what if I do this? What if I put curly braces or curly brackets around the variable's name? Notice VS Code is actually very subtly changing the color of it. So VS Code knows something interesting is going on here. Let me run this program, but I'm not done yet. Python of hello.py, enter. david, enter. OK, obviously not what I want. But I need to tell Python that this is a special string. This is what we're going to call a format string or an F string, a relatively new feature of Python in the past few years that tells Python to actually format stuff in the string in a special way. And the symbol via which you do this is a little weird, but this is what the world chose. If you put a F at the beginning of the string, right before the first quote mark, that's a clue to Python that, ooh, this is a special string. Let me format this in a special way for you. Let me now rerun the program. Python hello.py, enter, david, enter, and now we see the goal this whole time, hello, comma, David. We don't start with this way because I think if we did this the first way, you'd be like, why are we doing this? What are all these magical symbols? But this is just yet another way to solve the same problem. But let me propose that we consider now yet other things we can do with strings. And it turns out that even as we've been doing some relatively simple operations here, we've generally been trusting that the user is going to cooperate. And that is to say that they're going to actually type in what we want them to type. Now, just because they type a string, though, doesn't mean it's going to look the way we want. You and I, honestly, as humans, are actually in the habit on websites and apps of like accidentally hitting the space bar a lot, either at the beginning of our input or at the end. Maybe because the space bar tends to be so big, it's pretty common to get accidental spaces before or after some user's input. You and I are definitely in the habit of not necessarily capitalizing words like we should. If we're sending text messages, we're probably being a little quick and just sending everything in lowercase, for instance, if that's your style, if your phone's not fixing it for you. Maybe in a formal letter, you would capitalize things properly. But you and I, as humans, we can't really be trusted to type things in a nice way necessarily when using some piece of software, be it an app or a website or something else. But it turns out that strings themselves come with a lot of built-in functionality. And you can see all of that in Python's own documentation here. The string data type that we've been talking about comes with a lot of functionality built in that means that we can manipulate the user's input to do more than just join it with something else like hello. We can actually clean it up or reformat it in a way that hopefully looks a little better for us. So let me go back to my code here, and let me just demonstrate what might happen if a user doesn't cooperate. If I go ahead here and run Python of hello.py, enter, let me just sloppily hit the space bar a few too many times. Why? I just wasn't paying attention. And now I'm going to type in my name, david, and I don't know, I hit the space bar a couple more times. Like, it's kind of a mess. It's all lowercase. That's not going to necessarily look grammatically right. It's got spaces here and here. The program is going to print exactly that. And that looks really bad, at least if we're prioritizing aesthetics and grammar. Like, why are there so many spaces after the comma? This is not a very nice way to greet your users. But we can clean this up. It turns out that built into strings, which again is this data type, so to speak, this type of data in Python, is the ability to actually do things to that string. So let me do this. I can actually go ahead and do something like this. Name equals name.strip. And what does this do? Remove white space from string. And what do I mean by this? Well, on the right-hand side, notice I've written the variable name called name. I've then used a period or a dot. And then I seem to be doing what's a function, right? Anytime we've seen a function thus far, we see it's the function's name, print or input. Then we see a parenthesis, then another parenthesis. And that's exactly what I see here. But I'm using this function a little differently. Technically, this function is, in this context, called a method. And what do I mean by that? Well, if name is a string, aka stir, well, it turns out, according to the documentation, there's a lot of functions that come with strings in Python. And you can access that functionality by using the name of a string, like literally name here, then a period, then the name of the function, and then an open parenthesis and a close parenthesis. Maybe some arguments inside of those parentheses, but in this case, it doesn't need any arguments. I just want to strip the space from the left and the space from the right of the user's input. But that's not enough. I want to remember that I've stripped off that white space on the left and the right, so I'm going to use the equal sign again here. And notice that just as before, this doesn't mean equality. This means assignment from right to left. So when this line of code here, name.strip, returns to me, aka a return value, it will return the same thing that the user typed in, but with no more white space to the left or to the to the right. So then the equal sign assignment is going to copy that value from the right to the left, thereby updating the value inside of my name variable. So you can not only assign values to variables, you can absolutely change the value of variables by just using the assignment operator, the equal sign, again and again and again. And it will just keep copying from right to left whatever the new value should be. So now, if I rerun this program, Python of hello.py, enter, I have DAVID. Oh, let's do it again. Space, 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 DAVID in all lowercase, space, space, enter. It's better. It hasn't fixed my capitalization, so I'm still being a little sloppy with the first D, but it has stripped off all of that extra space. Super minor detail, right? Like this isn't all that exciting, but it just speaks to the power of what you can do with just a single line of code. Now, what else can I do here? Well, I could capitalize the user's input. Let me go ahead and try this. It turns out that I could also do this, name dot capitalize. So let me go ahead and capitalize user's name. And again, I'm making comments, and there's no one right way to write the comments. I'm just using some short English phrases here to remind myself of what I'm doing. What's now going on here? Well, let me go ahead and run Python of hello.py, enter, space, 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 DAVID, space, space, enter. OK, now it's looking prettier, right? No matter how the user typed in their name, even a little sloppily, I'm now fixing that. But let's try something. I'm getting a little curious here. How about this? Space, 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 DAVID, space, Malin. I'll use my last name now. Enter. OK, so ironically, capitalize is not really capitalizing everything we want. It's clearly capitalizing what? Just the very first letter. So it turns out that, again, there's other functions in Python that come with strings. And if we poke around the documentation, scrolling through a URL like that, I bet we'll find another solution, one of which is actually this. Let's actually change this to title. There's yet another function that come with strings called title that do title-based capitalization, just like a book or a person's name, capitalizing the first letter of each word. And this is just going to do a little more work for us. So let's go ahead and run this. And as an aside, I'm kind of tired now at this point of typing Python, Python, Python all the time. It turns out that when using a command line interface like this, you can actually go back through all of your old commands. What I just did a moment ago was I hit the up arrow. That immediately goes back through my history of all of the commands I've ever typed. So this is just a faster way now for me to repeat myself than typing everything manually. Let me go ahead and hit enter. Space, 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 DAVID, Malin, space, space, all lowercase, enter. Now it's looking better. Now I've capitalized things and cleaned things up. But what about my code? I've got like 8 lines of code now, 4 of which are comments, 4 of which are actual code. Do I really need this much? Well, not necessarily. Watch what I can also do in Python. Let me not bother capitalizing the user's name separately. Let me say this, and capitalize user's name. I can chain these functions together. I can add title to the end of this. And now what's happening? Well, again, with a line of code like this, you first focus on what's to the right of the equal sign. Then we'll get to the left of the equal sign. What's on the right of the equal sign? This line here. Well, what does this mean? Get the value of the name variable, like DAVID space MALIN, then strip off the white space on the left and the right. That is going to return a value. It's going to return DAVID space MALIN without any white space to the left or right. What do you want to do with that return value? You want Python to title case it. That is, go through every word in that resulting string and fix the first letter of the first word, the first letter of the second word, and so forth. And then, now we can finish our thought, copy the whole thing from right to left into that same name variable. And you know what? I can take this even one step further. Why don't we go ahead and do this if we want? Let me get rid of all that, and let me just do strip and title all on that first line. And now we've gone from like 8 lines of code to 4. It's a lot tighter. It's a lot neater. And even though reasonable people might disagree, it's arguably better because it's just easier to read. Fewer lines of code, fewer opportunities for mistakes. It just allows me to move on with my next problem to solve. All right, let me pause here and see if there's any questions on these methods. A method is a function that's built in to a type of value, like these functions are, or on f strings, which we saw a moment ago.
Yes, hi, thanks, David. So is there a way to remove the spaces between the spaces that I might have added?
Short answer, no. If you read the documentation at that same URL earlier, you'll see that strip removes from the left and the right, but not in between. In fact, there's 2 other functions that come with strings. One's called lstrip. The other's called rstrip that allow you to do one or the other. If we want to start getting rid of space in the middle, we're going to have to do a different trick altogether.
how many functions can we combine like this dot strip, dot title you have combined? So how many we can combine?
Yeah, a really good question. Technically, as many as you want. But at some point, your code's going to start to look really, really bad, right? Because the line of code is going to get really, really long. It's eventually going to maybe wrap around again and again. So at some point, you just kind of say like, that's too many. And you start breaking it up into multiple lines like I did, maybe reassigning the value to the variable as needed. And this is actually a good question. If I can pivot, Divya, off your question, I mean, what do people think? If we could go ahead and put everyone's hands down for a moment, let me ask this. Is the way I've done this now with strip and title and input all in the same line better than my previous approach? In Zoom, you can use the yes icon or the no icon. If you think this version is better, say yes. If you think this previous version was better, for instance, this one here, where we had everything broken out, say no. And then we'll see why in just a moment. I proposed earlier that reasonable people can disagree, and that's absolutely the case. Doing it one way or the other isn't necessarily best, at least if you can justify it. Let me go back to the most recent version here. All right, so we're seeing a lot of yeses and a lot of nos. Why don't we go ahead and call on one of the yeses if we could? Someone who's voting yes, why do you think the current version of this code is indeed better than the previous longer version of the code?
I think it's more readable, so I can say, hey, this is the name variable. It gets some input, and then remove the space and give it a title, and there you go. You have a hello name.
Yeah, I think that's pretty reasonable. It's very readable, at least if you're in the habit, as you are in English, of reading left to right. It just kind of flows very naturally as a result. The line is not really that long. It's certainly fitting nicely onto the screen, so I think that's a good argument. How about a counterpoint, though? Someone who voted no, if we could call on someone who thinks this is worse.
Because it's not readable at all. It seems like it's a very long line, so I think it's better to separate.
Yeah, I think that's persuasive too, right? It's getting a little longer. And even though my sentence here, what's your name, is relatively short, you could imagine that this could get even uglier quickly. If I were asking a longer question of the user, that's going to make this line of code even longer and therefore less readable. It might be less obvious to me or my colleagues that I am calling strip or that I am calling title. It might be kind of an unexpected surprise. So I think that's reasonable too. In short, there is no right answer here. And in fact, part of the process of getting better at programming is getting your own sense of style, or working for a company where they might prescribe which way is better than the other, because they just want everyone doing the same thing, even though reasonable people might disagree. Ultimately, though, so long as you have what's a pretty good argument in favor of one way or the other, like ultimately that's what's important. If you're just doing things because you don't really know which one's better, that's not great. But if and when you start to acquire opinions, and if your boss, if your teacher, if your colleague, your friend can challenge you and say, wait, why did you do it like this? They might not agree with you, but at least have an answer, and that should be sufficiently persuasive in general. Now, strings come with a whole bunch of other methods as well, among which is one called split, which can, as the name suggests, split a string into multiple smaller substrings, so to speak. For instance, if the human here is in the habit of typing in their first name, then a space, and then their last name, and you want to go ahead and greet them only by first name, well, we could actually leverage that single space between the first name and last name and split that string into two smaller substrings. How can we do this? Well, let me go ahead and in between these lines proactively comment that we're about to split user's name into first name and last name. And then let's go ahead and take that name variable, which currently contains something like, presumably, David space Malin. And let me go ahead and call split and pass in as the argument to split a single white space, thereby indicating that I indeed want to split on that character. Now, it turns out split's going to return a sequence of values, ideally a first name and then a last name. And we can actually, in Python, assign both of those values from that sequence at once to some variables. For instance, first, comma, last equals, and that's going to have the effect from right to left of putting the first such value in the first variable, the second such value in the second variable. So now on my last line of code, I can go in and say hello, not to the full name, something like David Malin. I can just say hello, comma, first. All right, let's go ahead and clear my terminal window, run Python of hello.py and hit enter. I won't bother with any leading white space this time, but let me go ahead and type in David space Malin, and crossing my fingers as usual, hello David is what we now see. All right, so we've seen so many examples thus far involving strings, but certainly programs and programming languages can manipulate other types of data as well. Let's go ahead and transition then to another very common type of data in Python, in programming more generally, namely integers, otherwise known in Python as int, int. So just as str, str is short for string, so is int in Python short for integer. Well, what's an integer? Well, just like in math, it's a number like -2, -1, 0, 1, 2, and all the way toward negative infinity, all the way toward positive infinity. But there's no decimal point in an integer. It's just a number like -2, -1, 0, 1, and 2 onward. That's an int. Of course, in the world of mathematics, there's lots of symbols that we use, and we've seen plus before, although we used it for a different purpose. But Python supports these symbols and more. And Python allows you to add numbers together, plus, subtract numbers, multiply numbers, divide numbers. And the only one here that might look a little strange to people or unfamiliar is this % sign, but it doesn't mean percent in this context. If you use a single % sign in a Python program, that's actually the so-called modulo operator, the operator that allows you to take the remainder after dividing one number by another. So we'll see examples of that before long, but the first 4 of these are perhaps quite familiar. Well, it turns out that in Python, you don't necessarily have to keep writing code in a file like hello.py and then running it in a terminal window. One of the features that many people like about Python is that it supports this, a so-called interactive mode. Like you can start writing Python code and immediately execute each of those lines interactively, especially if you don't care about saving all of your lines of code. You just want to execute code and get back some answers. So for instance, let me go back to VS Code here, and let me close hello.py, and let me click on the little triangle over here in my terminal window just to make it much bigger, just temporarily for a moment. So I'm not creating any .py file now. I'm just going to run Python by itself at my prompt. And you'll see when I do this, I get some cryptic looking output and the date and time at which the program was last updated and so forth. But I ultimately get 3 triple brackets like this. This is the interactive mode for Python. So I'm running the Python interpreter. And anytime I type a line of code in the interpreter, it's going to execute it immediately. I don't have to keep running Python again and again. It's as though in the human world, if you were standing next to a human who speaks some other language and you're just having a conversation with them back and forth, it's all happening, the translation, immediately. So what might I do in interactive mode? Well, I could do something like 1 + 1, enter. That's actually code. All right, you might not think of it as code, but if you know a bit of arithmetic and you know numbers and you know plus, that's valid Python code. And you can use Python really as a fancy calculator. But I could do other things too. If I want to print to myself hello, world, I can also print out that line of code there too, hello world. So it's interactive in the sense that the moment you execute a line of code, boom, you see the result. We're generally not going to do that because at least when teaching the language, we tend to want to do things incrementally. And we want you to be able to see where it is we came from. And we want to be able to try things again and again, especially if we make mistakes. But know that this is indeed a feature of Python, this so-called interactive mode. But let's focus for a moment now, not just on that interactivity, but really on the fact that Python apparently supports integers and mathematics and some of those basic operations. And let's see if we can't make maybe our own little calculator. So let me go ahead and open up VS Code again. And I'm going to shrink down my terminal window. And I'm going to create a new file called calculator.py. So to do that, recall, I can type code down here. And the name of the file I want to create, .py. Enter. That gives me a new tab up top. So I have already closed hello.py. I'm now in calculator.py. And let's just make a simple calculator that does some addition for me. But I'm going to do it in a file so that we can iterate on this and make changes for better or for worse over time. Let me go ahead and first declare a couple of variables. I'm going to do the mathematical thing of calling my first variable x, my second variable y, and then I'm going to give myself a third variable, z equals x plus y, and then I'm going to go ahead and print out z. Now, this program, admittedly, not very exciting or interesting. In fact, it's a little less interesting than printing stuff on the screen like before with strings. But we'll build on this and see what other features exist in Python that we can leverage. So hopefully if Python knows its math as well as I do, when I run python of calculator.py, I should see, hopefully, that 1 plus 2 equals indeed 3. All right, so not that surprising and not that interesting. And honestly, this isn't the most useful program because it's always going to calculate 1 plus 2 equals 3. Let's at least make this program, say, a little more interactive, right? We already know from previous examples how we can get input from the user. Let's bring back that input function. And let's do this. Let me go ahead now, and at the top of my code, let's change x to not be the number 1 always. Let's change it to be whatever the return value is of asking the user for x. And I can use any English or human language I want here. I'm going to say, what's x? Just like I asked before, what's your name? And I'm going to do the same thing for y. I'm going to use input again, but this time change the question to be, what's y? All right, at this point, I think I'm going to leave the rest of the code the same. Z equals x plus y, and then print z. But what's nice now is that I think I have a nice interactive calculator. Right now, it's not going to do 1 plus 2 all the time. It's going to do whatever the user types plus whatever the user types. So let's try this. Let me go ahead and run the program. All right, let's do it. 1 is going to be x. 2 is going to be y. And of course, everyone in agreement, 1 plus 2 equals 3. What's going on there? Either your math class misled you or I have misled you. Why don't we call on someone here to see if you can't help us reason through what the bug is? What's the mistake? Anjali, if I'm saying it right?
I think the issue is that it's concatenating strings because you use the plus operator instead of adding.
Perfect. So perfect intuition. We've seen that plus is used a little differently in the context of strings because it concatenates. That is, it joins the two strings. And that seems to indeed be what's happening here, even though the user typed a number. But the interesting thing here is that when you get user input, because they're using a keyboard on their Mac or PC or their phone, it is always going to be text. It might look like a number, but by default, it's coming from the keyboard as a string. That is as text. And so how do we go about resolving this if ultimately we don't want to treat those inputs as strings? We want to treat them as actual numbers. Well, we need another function. And it turns out in Python that you can convert sometimes from one type of data to another type of data, for instance, from string to int, by doing something like this. Let me go back into my code and let me change x before adding it to y to be whatever the integer version of x is, plus whatever the integer version of y is. So it turns out that int is not only a type of data in Python, it's also a function. And it's a function that if you pass in an input, like a string, so long as that string looks like a number, like 1 or like 2, it will convert it to an actual number that you can perform mathematics on instead. So if I now go back to my terminal window and run Python, and let me show you another trick. Calculator is kind of a long word. It's a little tedious to type. Notice what I can do in my terminal window in a command line interface in general. If I start typing CAL for calculator, I can actually hit tab to finish my thought. So autocomplete is possible in a terminal window like this. Type the first letter or few letters, and then boom, with tab, it'll finish your thought for you. Or you can go back in your history like I did with the up and down arrows. Let me go ahead and execute this. What's x? 1. What's x? 2? And there we go. Now we have a general purpose calculator that's going to support not just addition of 1 and 2, but now any two integers that the user types. And let me now improve this, right? We've seen how we can make improvements to code. And I don't know if it's going to necessarily be better, but let's try this. Do I really need the z variable? It's worth noting that I'm creating a variable called z, and then I'm immediately using it on the next line of code. Now, that's not that compelling because if you're creating a variable and then immediately using it but never again using it, did you really need to take the time to introduce another symbol and another variable just to use it once and only once? Well, maybe not. Maybe we don't really need z in this way. Maybe I should go and do something like this. Maybe I should get rid of z here. Maybe I should change this to be int up here, change this to be int up here, doing something that's pretty interesting now, even though it's a bit of new syntax. Notice that you can nest functions, so to speak. You can put one function call that is the use of a function inside of the use of another function, so that the return value of the inner function becomes the argument to, or the input to, the outer function. So just like in math, if you have parentheses, 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 your teacher probably taught you to focus on what's inside the innermost parentheses first and then work your way out. Same thing with programming. That's what Python's going to do. It's going to look at what's inside of the parentheses first. It's going to get the answer, and then it's going to pass the return value to the outermost function. So what happens on line 1 now is that the input function gets called first. Then the result of that, quote unquote 1, becomes the input to the int function. And same on line 2. The output of what's y becomes the input to this int function. And now there is no z. I could just do print x plus y. And because I've taken the time to convert each of those strings to an integer, I think we're OK. So let me try this. Python of calculator.py, enter 1 and 2. And we're still getting 3. Not 12, or not 12, 1, 2. We're indeed getting 3. And we've additionally gotten rid of the variable because we didn't necessarily need it, it seems, especially if only using it once. Well, here too, let me put everyone's hands down for just a moment, and let me ask, as before, this version now, which uses int around the invocations of input and does not use z, is this better than the previous version? If you want to vote yes, go ahead. Or if you prefer the old way, vote no. The old way, I'll undo all of this as we vote, instead looked like this. All right, and let me go back to now the newest version. Let's take a hand of the yeses. Someone who thinks this latest version is better.
I think this way is better because it allows us to immediately see what the x and y variables are with integers, and so we know what to expect from them. And also the print argument is more intuitive. We avoid too much clutter in the code.
I think those are all good reasons. It's nice and succinct. The lines of code are not very long. I don't need to know what z is because it doesn't exist. It just see print x plus y. I like that. But someone who prefers the older way, where we did have z, and we more explicitly passed individual variables to the int function.
Yeah, hi. I think the earlier version is better because when, if user input something else other than int, let's say they type 1 and 2, so it will be easier to debug.
This version, or this version here, or the old version?
The old version.
OK, that's fair. And in fact, I'm being very careful today as best I can not to mess up. I have thus far only inputted integers when I'm expecting integers. And Raul's actually pointed to something we'll come back to in the coming weeks. How do we actually handle errors? What if the user doesn't type in the number 1 or the number 2 or a number at all? What if they type in a word like cat, C-A-T? That's not a number, and I bet I can't convert it to an integer. But for today, I'm not going to focus on that. I'm just going to hope that the user cooperates, but that's not going to be the case. And so perhaps one way would set us up for more success when it comes to handling those errors. Now, for today's purposes, which is better? I like both. And I think both of you made very valid arguments in there too. So long as you have a justification that feels pretty reasonable, that's what ultimately matters. But acquiring, again, a sense of the trade-offs here. Well, is this way better? If so, why or why not? Just understanding what those trade-offs are. But generally speaking, prioritizing readability is a very good thing. Making your code readable for someone else is a very good thing, and very good for you too, so that when you wake up the next morning or you come back the next week or the next year, you too can read your own code without having to waste time trying to remember what you did. And simplicity tends to be a good thing too, keeping your code simple. So as you get more comfortable with programming, you might be tempted to try to combine an entire program into one long line. For instance, let me do just that. Technically speaking, we don't really need x in a variable. We don't really need y in a variable. We could also do this. I could just get rid of x and y altogether. I could then now eliminate that and make it just one line of code. OK, so in some sense, you might be inclined to think, wow, that's really nice. You made it one simple line of code. I would argue this actually isn't that simple. Now I think I'm starting to nest too many things. I have to think about print and int and input. I then have to notice that, OK, I've opened 2 parentheses. I've closed 2 of them. There's a plus. You're making me think too much. And anytime you make me think, you're wasting time. And anytime you complicate the look of the code like this, you're just going to increase the probability of mistakes, syntactical mistakes or logical errors in your code. So of all the things we've done, this is the only one that I would argue, yes, it's one line and it's nice and compact. It's just not readable enough. I would shy away from doing this, especially since 2 of those function calls are getting input from the user. But there too, reasonable people might disagree. But that's the kind of like visceral reaction you should have sometimes when code starts getting a little too complicated, a little too clever, perhaps for its own good. All right, well, it's not just integers we have access to. Let me propose that we transition from integers to one more data type here, namely a float. So again, a string is a sequence of text. An int is an integer, like -1, 0, and 1. A float is a number with a decimal point, properly called a floating point value. And you can think of the floating point as being the decimal that might be over here or over here with some number of digits to the left or the right. Mathematically, it's a real number, a number that has a decimal point in it. So that's a third type of data that Python supports. Right now, our calculator is somewhat naively assuming that the user is only going to type in integers. But if I want to support floating point values too, I think I can just make a couple of tweaks. So I'm going to go back to VS Code here. And instead of just converting the user's input, x and y, to integers on line 1 and 2, let's just make a simple change. Let's actually convert it to a float on the first line and a float on the second line here. Now I think if I go down to my terminal window and run Python of calculator.py, let's type in a number like 1.2 with a decimal point and 3.4 with a decimal point, and there we go. We have 4.6 as the final answer. So that wouldn't have worked before if I was only expecting integers from the user, but now that I'm expecting floating point values and accommodating it, I can actually now do floating point arithmetic as well. But suppose that I don't really want the final answer to be a floating point value like 4.6. I would be happy if we just round to the nearest integer. So I want to support the user typing in floating point values with decimal points. But at the end of the day, I just want to round the result to the nearest possible integer, for instance. Well, it turns out that here too, Python comes with some functionality built in. And in fact, if we return to this URL from earlier, wherein all of the Python built-in functions are listed, there's one called round, which does exactly as we would expect. It takes as input a number and then rounds it for us, for instance, to the nearest digit, to the nearest integer. But if we look a little closer at that documentation, as we can here, I'll provide an excerpt. This is what the function looks like in the documentation. And recall that earlier we looked at the documentation for print, and this is similar in spirit, that this shows us not just the name of the function, but its available parameters. That is, inputs that we can provide when using this function. But this is a little cryptic too, just like print was, and it adds some syntax. So let's see. The name of this function here is, of course, round. And its first argument is a number. Notice this time there's no star. There's no star objects like there was for print. The round function takes just one number as its first argument, period. That's its positional parameter. But notice this syntax. And this is a convention in programming or technology more generally. Generally speaking, when you see square brackets in documentation like this means that you're about to see something optional. And so what this means is that if you want to specify more precisely the number of digits that you want the round function to round to, you can specify it here by adding a comma and then that number. So if we read the documentation, if you don't specify a number of digits, you just specify the number to round, it rounds to the nearest integer. But suppose you want to round to the 10th place or the 100th place, that is 1 or 2 digits after the decimal point, you could additionally pass in comma 1 or comma 2 to be more precise. So that's what the documentation there is saying. Let's see if we can't then translate this to some actual code for us. So if I go back now to VS Code and I consider that I want to go ahead and round x and y, I can do this in a couple of ways. I could do round x plus y, but you know, I'd actually kind of prefer to break this now out into 2 lines. I don't have to, and reasonable people here might disagree, but I'd like to revert to a scenario where I'm printing z so that I can just a little more clearly to myself, to others, say z equals the rounded result of x plus y. It's not necessarily the better way to do it, but I'm a little more comfortable with breaking out my thoughts one at a time, especially if I want to start commenting each of these chunks of code. All right, let me go down to my terminal window now and run Python of calculator.py. What's x? Let's do 1.2 again. Then let's do 3.4. And now it was previously 4.6, but now it's been rounded up to the nearest integer, which of course is going to be 5. All right, what if I wanted to change this a little further? What if I wanted to support maybe really big numbers, irrespective of rounding? Let's just do something like this. Let me go ahead and run Python of calculator.py again. And let me just add 999 plus 1. And notice I don't have to type decimal points. Even though I'm converting to float, my program will just allow me to type decimal points, but I don't need to oblige. The answer, of course, here should be, and is in fact 1,000, whether or not we round. So that's just arithmetic with integers here. But in the US, we tend to format long numbers by putting commas after or before every triple of digits. Other countries flip it and they use periods and commas instead. That's a system setting. You can change that on your own Mac or PC or device for Python or any language. But for me, I'm using the US approach here, which is periods for decimal points and commas for separators. What if I wanted this to be outputted as 1, comma 000? Just to make it a little more clear that it's 1,000 and not something like 100. That's even more useful when it's like 1,000,000, 1, comma 000, comma 000. Wouldn't it be nice if we could automatically output those numbers as well? Well, it turns out that we can. There is a way using Python to actually specify that we want to include commas like this. And here we have an opportunity to bring back our old friend, the f string. First, let me do something that's not that productive. First, let me do this. Let me print out the value of z. But wait a minute. I can't just say quote unquote z, because that's literally going to print z on the screen. So let me wrap it with those curly braces like I did before. But that too was not enough. I literally needed to add an f at the beginning of my string to tell Python that this is an f string, a format string. That now is going to print out, not very interestingly, just the value of z itself. So that I'm going to great lengths just to print z, when really I could have just passed z as the sole argument. But just to ensure that I haven't broken it, let's do this again. 999 plus 1, enter. OK, it's still 1,000. So I didn't make anything worse. But notice, and this syntax is unfortunately a bit cryptic, notice that I can actually do this. I can put a colon after the z, and I can put a comma thereafter. This looks very cryptic, admittedly. And even I have to constantly look things like this up in the documentation to remember the syntax. But here, let me run it again. Python of calculator.py, 999, 1, and now notice that the number has been automatically formatted for me. If I were in a different country or locale, I could absolutely override this to use periods instead of commas or vice versa. But in this case here, it's just happening for me automatically. So there too, we see a hint of what it means to really format a string. There's even more power, more powerful capabilities built into that. All right, let me pause here to see if there's any questions now on floats, on rounding, or on this use of f strings.
Yes, so I have a question. So when using floats, is there like a cap to how many decimal points it can have?
A really good question. So floats, yes, and this is a problem we'll revisit before long. Floats cannot represent numbers infinitely precisely in a nutshell because computers only have so much memory. They only have a finite amount of memory. You and I only have a finite amount of hardware inside of the computer. So at some point, they're going to have to round. Right now, I'm rounding automatically. Effectively, computers will eventually have to do that for us. But we'll see that as a fundamental problem before long. Allow me to turn back just for a few final examples on float before we introduce a few final examples that allow us not just to use functions, but to make our own. Let me propose that we also try our hand at a bit of division here. Let me propose that we modify this calculator now to still take a couple of floats, but let's now just do something a little simpler than a little different from this, just doing x divided by y. And let me go ahead and get rid of my format string and just keep it simple for now, printing out z instead. And what are we going to see here? Well, just some simple division. So Python of calculator.py, let's do something like 2 divided by 3. And of course, I get 0.66666. And to Ethan's question a moment ago, it does seem to be finite. It's not rounding in a weird way here, but I only seem to see so many digits. That's an inevitability of using a float in this way. By contrast, just so you know, integers nowadays in Python can be as big as you want them to be. Unlike other languages, there is no upper bound on how big an int can be now in Python, but there is a bound on just how precise a floating point value can be. All right, now that I've got some simple division working here, let's go ahead and round this. It would be nice to round this really long number, 0.6666666, and so forth, to maybe just 2 decimal places. We've seen how to do this with round, though, at least in its documentation. Let's just round this, not to the nearest int, by passing in just x divided by y, which is one argument. Once the math is done inside of the parentheses, I don't want to pass in just one argument. I want to pass in 2 so that I can specify n digits, number of digits, which recall was the second parameter for round. Let me go ahead and run python of calculator.py. I'll do the same thing, 2 and then 3. 0.67. So here too we see a way of rounding now, not just to a nearest integer, but to a nearest number of digits. But there's another way to do this here. And in fact, this evokes our f string example again. Let me go ahead and change this. Suppose that you didn't remember the round function, or for some reason you didn't want to use it. You instead want to just use a format string. Well, let's go there. Let me do quote unquote z. But let me surround it with those curly braces. Let me add the f at the beginning. And again, this is not interesting yet. This is just going to print out z, but I'm adding a lot more complexity to turn it into an f string. But notice, I can do something else after my variable name, after the colon. If this were going to be a big integer, I might want to use a comma like before to separate each triple of numbers with commas. But I don't. I'm going to use a different sequence of characters. I'm going to say 0.2f. And this, too, is one of these very cryptic things I have to constantly look up because I forget if I don't use it that often. So don't be intimidated if this looks especially weird. But this is, according to the documentation, the way you specify using an f string how many digits you want to print. So let me run this version of the calculator. Type in 2 and then 3. We get the exact same thing. But again, this is just consistent with my claim that in programming, we can so very often solve the same problem in multiple ways. This is just now the f string approach to that very same problem. All right, which one is better? It depends. In this case, they're pretty equivalent. You could imagine, though, it being useful to use a function sometimes so that you can pass in an argument like n digits as that second argument. Or you can imagine just deciding in advance that you want 0.2 and then writing it like this. Let's transition now from focusing on strings and on integers and on floats to focusing now on functions themselves. We began today by focusing on how you can use functions that come with Python. But wouldn't it be nice if you could invent your own functions, especially if, to our point earlier, you find yourself solving the same kind of problem again and again? It's nice that Python comes with the print function because it's really useful to be able to print things on the screen. But wouldn't it be nice if you could print specific things on the screen by just calling your own function? Well, let me propose that we do this. Let me go back to VS Code here, and let me propose that we go back to hello.py. I'm going to reopen hello.py where we left it before, and I'm going to go ahead now and propose that we consider how we can start improving this further by making our own function. I have written so many programs today that just say hello. And each time I'm using print, but wouldn't it have been nice if from the beginning of today we could just call a function called hello that just says hello for us? Now, the authors of Python years ago didn't think that we need a special function just to say hello, but I would like that to exist. I'm saying hello so many times, I just want to be able to call a function hello. So I'm going to start from scratch here. I'm going to delete all of my code from earlier, and I'm going to pretend for the moment that a function called hello exists. And I'm going to do just as I did before. I'm going to get the user's name with the input function, asking what's your name, question mark. And now I'm going to call a function hello, and then I'm going to print out the user's name. Now, I will admit hello doesn't exist, so bad things are about to happen, but let's see what. Let me go down to my terminal window. Let me run python of hello.py. I think the first line is going to be OK, because that worked before. And indeed, it's prompting me for my name. So let me type in David. The second line of code is apparently calling a function that looks like it's called hello, because why is it a function? It has a parenthesis and a closed parenthesis immediately after it. And that's what every function we've used has looked like. But Python's not going to recognize this one. When I hit enter now, I get a name error. Name hello is not defined. Did you mean help? I didn't, although it's opportune. That's what I need at this point, is some help. But I am encountering this error because why? The function just doesn't exist. So how do I make this function exist? Well, I need to create it myself using this keyword, def. Def for define. So here too, just as str is short for string and int is short for integer, def is short for define. If and when you want to define, create, invent your own functions, you can do so using now this keyword in Python. So let me go back to my code here and let me propose that we define this perhaps in this way. At the very top of my file, I'm going to first take a moment to define a function called hello using def hello, open parenthesis, close parenthesis, colon. What this means now is that Python is going to treat every line of code that I indent underneath this one as the meaning of this new function hello. So def is important, as is the space. I get to choose the name of the function, and I'm choosing to call it hello. The parentheses with nothing inside means that this function at the moment is not going to take any inputs, no arguments there too. The colon means stay tuned for some indentation. Everything that's indented beneath this line of code is going to be part of this function. It's going to be a super short function, one line of code. It's just going to print out quote unquote hello. But now on lines 1 and 2, I have invented my own function hello. Notice these dots that have now magically appeared here. This is just a setting of my text editor, VS Code in this case, that's just making super explicit to me that I've hit the spacebar 4 times, or equivalently the tab key once, which is converted automatically to 4 spaces. Generally speaking, I'm going to need to make sure that all of my indented code lines up now so that Python knows that it's all part of the same thing. But it's easy in this case because it's just a single line. But now, thanks to lines 1 and 2, the function hello will absolutely exist when I'm ready to use it on line 6. So let me go down to my terminal window and run python of hello.py, enter. Here comes my name again. And now, when I hit enter, I now see hello, David. All right, we've kind of regressed though, right? This is not nearly as pretty as it once was. I think we can probably do better than this by improving things further. Why don't we consider, though, how we might, say, parameterize this same function? That is to say, can we customize hello to maybe take the user's name as input so that we can say not only hello, but the person's name all on one line, all in one breath? Well, I think we can do this. Let me propose that we do this as follows. Let me go ahead and up in my code. Let me, inside of these parentheses, let me come up with my own parameter name. I have complete choice here. And I'm going to say that the name of my parameter will be the word to. Why? Because I want my function to sound like the verb it represents, hello. But who do you want to say hello to? Well, I'm going to call my parameter for this function to, just because in English it kind of sounds nice to me. Hello to. Who do you want to say hello to? That's why I'm calling this parameter to instead of something simpler like x or y or z. All right, well, what do I want to do with the word to? Well, I can do a couple of different things. We've seen like so many different ways to implement hello. Let me just add a comma there for grammar's sake. And then let me put the word to after that as the second argument to the function hello. There's other ways we can do this, and we've seen so many, but this one looks a little clear to me, I'll say. What's going to happen next? Well, I don't think I need this extra print line here. I think what I'm going to do is this. I'm going to go ahead here and print out not the person's name manually. I'm going to instead say hello parentheses name. So what am I now doing? On lines 1 and 2, I'm defining my very own function called hello. But this time, that function has been designed to take a parameter, a single parameter, as input. And I'm using the value of that parameter, which I called to plug into print so that I see not only hello, but also that person's name. What am I doing on line 5? Same as always. I'm just getting the user's name. Line 6, I'm not only calling hello, I'm passing as input the name variable as an argument so that that's what gets passed into hello. And what's happening here is essentially this. Even though the variable is called name here, when the function itself is called, the computer assumes that that same value is now called to. So name is essentially copied to another variable called to. so that in the context of hello, I can say hello to that variable instead. And we'll see in a moment what happens if we don't keep those straight. Let me go ahead and run Python of hello.py, enter. What's your name? And now I'm crossing my fingers, enter. There we go. We're back in business. But now I have my own custom function called hello that's allowing me to say hello to a specific person. And here's where now things can get really fancy. What if you wanted your hello function to say hello to someone specific, but you know what? If you don't know who you want to say hello to, you want to say hello to the whole world, you can give parameters default values. We've seen that. Recall that with print, there was a default value for sep, for the separator. There was a default value for end, the line ending. We can do that too. And here's the syntax. If you want the value of this parameter by default, if not provided by the programmer, to be equal to quote unquote world, you literally do that in the same line you're defining the function. And I'll admit it's starting to look more cryptic, but I'm still just defining a function called hello. It takes a parameter called to, but I'm assigning it with the equal sign a default value of quote unquote world, just in case the programmer doesn't call hello with an argument. And we can see this here. Let me change my code to use hello in two ways. On line 5, I'm going to very simply call hello, no arguments. Then on line 6, I'm going to get the name. Line 7, I'm going to call hello with an argument. So you'll see hello now being used in two ways. Let me go ahead and run Python of hello.py. I'll type in my name. Oh, interesting. Notice I already see hello world, but that's expected because line 5 happens before line 6. But once I type my name, now the program's going to be a little more polite and say hello to me personally. So there too, we see with relatively simple but new syntax how you can implement functionality very similar in spirit to what the print function gave us automatically. Now you have control over doing that yourself. But let me now make this point too. One of the whole points of defining your own functions is, one, just to avoid having to repeat yourself again and again. You don't have to actually keep reinventing the wheel and keep using the print function again and again and again if you just want to say hello. Wouldn't it be nice now if I could kind of move this code that I wrote for defining the hello function, and just to be dramatic, I'm going to hit enter a whole lot of times, 50 lines down, and put my definition of hello way further down in this file. Why? Well, just in the spirit of out of sight, out of mind. Because if I now rewind to the start of my program, now you can sort of take for granted that, oh, hello is a function. Why? Because it's there on line 1 and it has an open parenthesis and a closed parenthesis, which up until now has meant call this function. And then on line 2, we're getting a variable from the user by typing in their name, and then we're calling hello, passing in that value. Well, at this point, I can just take for granted that hello exists, even if it's way down further in the file, or as we'll see in future weeks, even if it's in a different file altogether. But there's a problem here. And let me go ahead and run this version of hello.py. Notice that as soon as I run the interpreter, Python of hello.py, I see a name error. Name hello is not defined. Again, did you mean help? Well, again, fitting. I do need some help here, but I didn't mean to call the function help. The problem here, though, is that Python is just taking me literally. I have defined my function hello all the way down here, but I'm trying to use it way up here, and that's not allowed. Python's interpreter is going to take you literally, and if you use a function, it must already exist by the time you are calling it. So how do I fix this? Well, apparently I can't do that. I have to define any functions I want at the very top of my file. But that too could get me into a bit of trouble eventually, because if I constantly have to define a function above where I want to use it, you're kind of writing code in reverse. You're constantly writing functions up here, up here, up here, as opposed to like writing your code logically top to bottom. So let me fix this in a more standard way, which is to do this. Generally speaking, you do want to put the main part of your code at the top of your file. And in fact, I'm going to go so far as to define my function called main. It's not a requirement, but it's indeed a convention. And this just connotes to the reader that this is the main part of my program. I'm going to get rid of my empty hello call now and only pass in one version with hello name. And then down here, a couple lines further down, I'll actually define my hello function. Unfortunately, now that I've reordered the functions in this way, by putting the main part of my code at the top and hello at the bottom so that my logic kind of flows top to bottom, if I go ahead and run Python of hello.py, enter, nothing whatsoever happens. If I do it again, nothing whatsoever happens. Well, why in the world is this? Well, just because I've defined a function called main and I've defined a function called hello doesn't mean that I've actually called, that is, used either of them. Yes, I'm using hello inside of main, but no one is telling Python to actually use or call main. So in order to tidy this up, the last thing I need to do in this file, it seems, is actually call my main function. And in fact, by calling my main function in this way, it gets me out of trouble because now I'm defining main first, but I'm not calling hello yet. I'm defining hello next, but I'm not calling hello next. I only, at the very end of this file, call main, which has the effect of running this code up here, which has the effect of running this code down here, and it allows me, therefore, to organize my file and order my functions in any way I want, including main at the very top, and solving, ultimately, that problem of Python not knowing what's going on. Now, it's important to note that I defined my function hello as taking an argument 2, and then I passed into that function the value of the variable that I wanted to say hello to, that is the variable called name. Because suppose I had done something a little bit differently. Suppose that I hadn't defined hello as taking an argument, so I just remove mention of 2 and its default value world, and I go back up to my main function and I just call hello itself without passing in any arguments. And now let me go ahead and make one more change, one more mistake technically. Let me go ahead and just try to naively print out the value of name in the hello function. So now to be clear, in my main function on line 2, I'm defining my variable called name and assigning it the return value of the input function from the user. I'm then just calling hello. In my hello function, which now no longer takes any arguments, I am calling print, passing in hello, comma, and then immediately passing in name, the variable into which I got the user's input. But the catch is that name exists now only in main. And so watch what happens when I try to run this version of the program with Python hello.py. I hit enter. I'm prompted for my name, DAVID, enter, and a name error. Name, quote unquote, is not defined. So it turns out that this is actually an issue of what's called scope. Scope refers to a variable only existing in the context in which you defined it. So insofar as I define this variable name in my main function, I can only use that variable in my name function. I can't use it as I've tried to here in my hello function. It doesn't exist in that so-called scope. And so this is why now, if I rewind and undo all of those changes, you'll see that I'm deliberately passing main from my main function into my hello function. And now in the hello function, it technically has a different name. It's called to in that context, but that's fine. It's completely up to each individual function to name its own variables or name its own arguments. But this is a way now that I'm handing to the hello function the value of that variable so it can be printed by hello as well. And there's one final flourish we can add here. Now that we've implemented hello, you'll notice that hello only has a so-called side effect. It only prints out something to the screen. Well, what if I also want my function to not have a side effect per se, but actually hand me back a value? Recall that the input function returns a value, the string that the user typed in. Recall that the int function returns a value. The float function returns a value that was passed into it. Well, you can use one final keyword here, literally return, to return a value explicitly yourself. In fact, let me go back to VS Code here, and I think we'll return our attention to calculator.py and see if we can't implement one other version of calculator.py that actually has our own function that even returns a value. So I'm going to go ahead and open up calculator.py, and I think this time I'm going to throw everything away as before, and I'm just going to start practicing what we're preaching here. Define a function called main, which is now going to be the main part of my function. Let's go ahead and now declare a variable called x and assign it to the converted version of the user's input after asking them what's x. So again, a line of code quite like we've done before. And suppose now that what I want to do is square this value. I want to take the number that the user's typed in and raise it to the power of 2. So 2 squared would be 4. 3 squared would be 9. 4 squared would be 16, and so forth. Well, how do I go about implementing a function literally called square, which actually doesn't come with Python built in? Well, let me assume for the moment that it does exist, and let me say something like this. Let me go ahead and say that printing, how about x squared is comma square of x. So what have I done? I've defined a function called main, and I've implemented 2 lines. The first of these lines prompts the user for a value x and converts it to an int and stores it in a variable called x. On line 3, I then say x squared is, and then I pass a second argument to the print function, whatever the return value is of a square function. But square doesn't exist, and I'll show you this here. If I now call main at the bottom, and I run Python of calculator.py, I'll see that x is 2, and then I see a whole bunch of errors. A name error, name square is not defined. So this isn't a typo here, it's just the function doesn't exist, but I think I can make it exist here. Let me go ahead and define another function called square. This one's going to take in a number, and I'm going to call it generically n, as many a programmer would, just to represent any old number. And then what do I want to do in order to square n? Well, a number squared is really just itself times itself, so I'm going to do this, n times n. But it's not enough just to do the math yourself, n times n. You're going to have to return the actual value, n times n, and that's our new keyword here. When I now do this, watch what happens. Python of calculator.py, enter, x say shall be 2, x squared is 4. Let me go ahead now and say x is now 3, x squared is now 9. So I've implemented my very own function that returns the square of a value. And because I'm using the return keyword, that ensures that I can pass the return value of this, just like the return value of input or int or float, to another function, like print instead. And here too, there's going to be so many ways to solve this same problem. I can actually raise n to the power of 2. We've not seen the syntax before, but if you use 2 asterisks like this, 2 stars, that raises the thing on the left to the power on the right. Or it turns out there is in Python a function called pow for raising something to the power that takes 2 arguments, the first of which is the number, the second of which is the exponent. So there too, there's just so many ways to actually solve that same problem as well. So ultimately, what have we done here? We first introduced functions. These actions are verbs, many of which come built into Python that you can just use in your own code. We then introduced variables via which you could store those return values and then maybe do something more with it. At the end of the day, too, you now have the ability to invent your own functions to solve simple problems like hello, or in the weeks to come, much more sophisticated, more challenging, more fun problems as well.